Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Well, dear students, now let us understand the derivative of f of x at x is equal to a. So, if f of x is a real valued function, then the derivative of f of x at x is equal to a is given by. So, there are two different formulas and both are similar. So, you can either use this or that. So, this is the first principle. You can use any one of the formulas to find the derivative of the function at the given point a. So, what do you mean by the derivative of f of x at x is equal to a? It is f dash of a. And how do you find it? Both left hand derivative and right hand derivative must be equal, then only this limit will exist. Alright. So, I am just writing one limit here. It means that both left hand derivative and right hand derivatives are equal. So, what is it? Limit h tends to 0, f of a plus h minus f of a divided by h, the first formula which I told you already. Now, there is a second form of this formula. The second form is this: f dash of a can also be written as limit as x tends to a, f of x minus f of a divided by x minus a. So, this is the second form. How do you get this form from here, right, or vice versa? You can take the first one and get the second, or you can take the second and prove that it is equal to the first. So, I will go the vice versa method. So, I will just take this limit and get this by just using a substitution. And what is that substitution you see here? In place of x, what do I need? A plus h. Therefore, what do? I take x is equal to a plus h, alright, in the second derivative. Then what happens to x tends to a? As x tends to a, what happens to h? What is h from this? h is equal to x minus a. So, when x becomes a, that will be a minus a, that means h will tend to 0. So, make these two changes in this limit. So, f dash of a will be equal to limit in place of x tends to a, what I need to write now is h tends to 0, and in place of x I must write a plus h, because x is substituted as a plus h. Then what about f of a? Doesn't change, that is f of a itself. And what about this x minus a? So, in place of x minus a, now I should write h here. So, did I get the first one? Yes. Alright. So, you have both the forms before you, you can select any one of them. So, why did I give the second form here? In some questions you will see this form. So, you have to identify, if at all you have this form, you should understand that that is f dash of a, right. So, now that is at a given point a. So, what if you need at any point x, alright. So, if you need with respect to x the derivative of f of x, that is like f dash of x, right. So, in place of a you just have to write x here, that is x plus h minus f of x divided by h as h tends to 0. So, that is the general formula. You can find the derivative at any point x, alright. The previous one was just at one given point. So, this is in general. And when do you say a function is differentiable? If it is differentiable at every point. So, it must be differentiable at any x, alright. So, you should be able to find the derivative at any given point x, then we say the function is differentiable everywhere. Well, let us move to the next concept.
Don't forget to like our video and subscribe our YouTube channel for all the updates.